if you haven't printed out the notes for this section, you might want to go ahead. This formula sheet we're going to use all throughout Chapter 8. Make sure you have it handy when you're doing your homework, or you're taking a quiz, or taking a test. So we'll be using some of these formulas today, and then we'll be using some later. Now in Lesson 15, we're just going to start our geometry section. And we have an angle here, and the correct way to name an angle, you can name an angle ABC, angle CBA. You always put this point in the middle, or you can just call it angle B. This point right here is called the vertex. And sometimes they'll have just a little curve drawn here and put a variable here. And if we did that, we could just call it angle X. So there's different ways you'll see an angle. Now it says it's acute, right, obtuse, or straight. This is an acute angle. Acute angles are always between 0 and 90 degrees. A right angle is 90 degrees. An obtuse is more than 90, and a straight angle will be a straight line. But we'll be seeing some more of these later. Now in the second one, it says find the angle X without a protractor. Well, we need to know a fact. All three angles in any triangle, this one's kind of special, it's called a right triangle, but any triangle add up to 180 degrees. You might even want to put that on your formula cheat sheet. So this is 30. This box here indicates that that is 90 degrees. So we can add those up and then subtract from 180. So those two angles add up to 120 degrees, and we know the total is 180. So it must be 60 degrees, and we want to make sure we label that answer there. Okay, now let's look at this one here. It says find the angle here without a protractor. Well, let me just highlight that, okay? Now, there's another fact in geometry. When you have intersecting lines, the opposite angles are equal. And so y would be 55 degrees. There's no work there, we just have to know that fact. Okay, let's see. Now here we have these two lines here, and they're running what we call parallel. Well, when you have parallel lines and then you have a line intersecting parallel lines, what's true is alternate angles are equal. So if this is 40, this is 40. We learned on the previous page that opposite angles are equal, so this would be 40 and this would be 40. So alternate angles and then, of course, opposite angles. Well, what about angle X? How are we going to find that? Well, this is 40 degrees here. Make that a little bit neater. 40 degrees. And if you look here, let me get another color. These are adjacent to each other. If I look at these together, I get a half circle. And a half circle is 180 degrees. So if we have two angles that form a straight line, and you can see that there, two angles that form a straight line, together they're 180 degrees. So to get this angle here, you can see it's obtuse. If you want to turn your page, you can see, let's just flip it around here. This is acute, 40. This one's obtuse. Together, they would be 180 degrees. So for angle X, we have 180 minus 40, which is 140 degrees. Now, another one would to figure out without a protractor. Well, we know all three angles add up to 180. We wrote that fact down on the first page. Now, this is what we call an equilateral. I'll write that down. And an equilateral has all three sides equal. Well, guess what? So are all three angles. So we're going to divide that up by 3 because they're all going to be the same. And 180 divided by 3 is 60 degrees. Okay, let's see. Here we have to get angle Y without a protractor. Well, on our first page, we were able to find a missing angle if we knew the other two. Well, I know this one's 90 degrees, but I don't know this one here. Well, if I look at the angle next to it together, they make a half circle. So together that would be 180. So 180 minus 140, this would be 40 degrees for this inside angle. So let's add 90 and 40, which is 130. Subtract from 180, and that missing angle is 50 degrees. Okay, this next one, a rectangle, find perimeter and area. I don't specifically have that on the formula sheet. That's just something I think we all need to know, because this is something we would work with a lot, working around our house or in our yard, doing different projects. A lot of times we're dealing with a rectangle. Let's write our formula, and you can add that to your formula sheet if you want to. So perimeter of a rectangle means the distance all the way around. Well, you know, if that's 16, that's 16. If that's 30.6, that's 30.6. So we take twice the length plus twice the width and add them together. And let's see, so we get 2 times 30.6 plus 2 times 16. I've got a scientific calculator, so it follows the order of operations. It'll multiply and then add. And perimeter is going to be in inches. That double mark means inches. Area for a rectangle is length times width. So side by side. And so we get 30.6 times 16, and that's 489.6, and that will be in inches squared. Make that 489 look a little bit better there. Okay, here we have what we call a parallelogram. I'll write that down. And we're finding perimeter and area. And if we look at our formula sheet, I have my area, pretty simple, it's base times height. Now notice height here. Your height is always measured standing straight up. When we measure our height, we stand straight up. We don't lean over. So your height is always measured, what we'd say, perpendicular to our base. So we will not use this slightly angled side here. We're going to use the base and the stand-up straight height to find the area. Well, I know we're finding area and perimeter. Why don't we find the area first, because that'll go pretty quick. My area is my base. If this is 12, this base is 12 also. So this is 12, and from here to here, they've written it outside, that's 4.5 inches. So the area is 12 times 4.5. I'll make that 4.5 just to make it simpler to put in a calculator. And if I multiply that, I'm going to get 12 times 4.5. I get 54 inches squared. Now my perimeter is going to be the distance around the edges. So it's going to be the 12, 12, 6, and 6. So I've got 12 plus 12 plus 6 plus 6. So you really don't need a perimeter formula for every straight-sided figure. You're simply adding the sides. So it's just the total of the sides. So we don't have to have a special formula every time. So that's 12, 12. That would be another 12, and that would be 36 inches. Perimeter's in inches. Area is in your squared units. Okay, here, perimeter and area. Again, for perimeter, we're simply adding the sides in any order you wish. And that's going to give me 32 feet. That mark is for feet. Now, to get the area, well, we need a formula. We come over here, and I don't see anything that looks exactly like it, but look here. I've got a figure that has two parallel sides. Well, if I flip this over, I have two parallel sides. This is a trapezoid, okay? And for a trapezoid, we add the two bases. Those are the parallel sides. Put that in parentheses. The height is measured straight up and down between the bases, and then we multiply by a half. So if we look here, one of my bases is 7, one is 3. Okay, so I'll call that base 1, and I'll call that base 2. It doesn't matter which, because you're adding them together. And your height is going to be the 9. So if we flip back around, our area is 1/2 times the height times base 1 plus base 2. And like I said, if it helps to do that right there, to read it. And then that's going to be 10 times 9 times 1/2. I'm just going to do 0.5 times 9 times 10, and I get 45, and that is in inches squared. Okay, here's another trapezoid. You might want to pause the video here and try this yourself. For the perimeter, I'm just going to add up the outsides. And like I said, you might want to pause that now because I'm just going to write the answer. And we get 44 centimeters. My area is going to be 1/2. I'm going to go ahead and write down my work here. The height is 8. Remember, it's always measured up and down between the two bases. This doesn't have to be flipped around like this one. This was tipped over sideways, and we want to look at it like this. The bases are parallel. And then we add these two sides here. Half of 8 is 4. I'm going to do some of this in my head. 6 plus 18 is 24. And we multiply that, we're going to get 96 square centimeters. And so you can write centimeters with a little 2, or you can write square centimeters. Okay. We have a perimeter problem here. Remember, we don't need a special formula for each thing. And so to get the perimeter, this side is 16. Let me use my highlighter here. If this side here, vertical up and down, is 16, these two must be 16. I can't tell you exactly what each one is, but I know together they have to be 16 because we're assuming right angles here. And so that's 16 and 16. And then this side run along here is 24. Well, these two together must be 24. Again, I don't know them individually, but I don't care because I'm just looking for perimeter. So we'll add in 16 twice. So we have 16 and 16 and 24 and 24. And that's going to give me a perimeter of 80 meters. Okay, and let's do this last one, and then what we'll do is we'll finish the last sheet in another video. Okay, we have a rectangular window, has measurements 36.5 inches by 49 3/4. Calculate the area. Your area is 36.5 times 49.75. And let's get a calculator for that. Okay, and it says to round to the nearest square inch, or in other words, whole inch. So we're going to round it to 1816. They want a whole number. That's going to go up to 6 because the 8 next door, and that is going to be in square inches.